So when I think about that video we just looked at, the thing that I graphed was this. And the graph that I got looked like a horizontal line that went through y equals 1 on the x-axis, or the y-axis. So I'm thinking that graph could have also been achieved by typing in y equals 1. So if those give me the same graph, that's an identity. Okay, but that's not a proof. That's speculation. I think I saw that. So I'm wondering how I could prove that. And ideally, you've already thought about this. Ideally, you've already thought that sine is the opposite over the hypotenuse. And cosine is the adjacent over the hypotenuse. And if I think about those, if I think about what I can do algebraically with those guys, that would be opposite squared over hypotenuse squared, because that's how fractions work. Adjacent squared over hypotenuse squared, because that's how fractions work. And now I've got a common denominator, so I can say this. And now I'm like, oh, well, that's kind of interesting. But I wonder where did these things come from? From what picture? Well, that's some kind of a right triangle where I've got some angle, and I've got an opposite side, an adjacent side, and a hypotenuse. And this squared plus this squared is equal to this squared from Pythagorean theorem. So h squared over h squared, oh my gosh, that's 1. There's your proof. Okay, so this guy here, because of this relationship here and where that proof came from, this is called a Pythagorean identity. Sine squared plus cosine squared is 1, and we are going to use that a lot. But there's actually 3 Pythagorean identities. And when you get to calculus, you're going to want to know all 3. But they all stem from this one relationship here. So I'm going to start with that. Sine squared plus cosine squared is equal to 1. All right, now let's just say that I have a real bias. I really hate cosines. I really, really dislike them. And I would like to get rid of all of the cosines that exist in this equation. I could do that by dividing every term by cosine squared. And based on what we learned yesterday, I know some things. First, I know that cosine squared divided by cosine squared is just going to be 1. Second thing is that this is really sine over cosine squared. And we learned yesterday that sine over cosine is just tangent. And I learned yesterday that 1 over cosine is secant. Well, I learned that a long time ago, but yesterday we looked at it again. So secant. So this is another Pythagorean identity. And usually in calculus, you might more commonly see it like this. Same thing, just moved around. Okay, so that's our second one, whether it's in this form or this form. That's number 2, Pythagorean identity number 2. And that came from the fact that I have an absolute bias against cosines. But what if my bias wasn't against cosine? What if my bias was against sine? I hate sine. I would like to eliminate them all. Get rid of all the sines. It'll be anarchy. There are no more sines. All right. So if I divide everything by sine squared here, 1. Ooh, what's that? Think about that. What is that? I think that's cotangent. What's that? I think that's cosecant. And this is Pythagorean identity number 3. And again, you can move these terms around. You can move that 1 over to there. So 3, 2, 1. Welcome to the world of Pythagorean identities.